Thank you, Dr. Prokoff. I've often thought that there's more to the heat island effect for temperature readings than even the IPCC gives credit to, and further confirms my belief. Next up is Dr. Paul Wagner, distinguished professor, distinguished scientist at the Connecticut Agricultural Experiment Station in New Haven, where he was formerly director. His research has spanned micrometeorology, stomates or leaf pores, plant disease epidemiology, and land use by cities, crops, and forest. He's a member of the National Academy of Sciences and has participated in studies of adaptation to climate change for the American Association for the Advancement of Science, Council for Agricultural Science and Technology, and National Academy of Sciences. Adaptation is what I spoke about, so something near and dear to my heart. Dr. Wagner.
Thank you. I represent the trees. My full title is Returning Forests Under a Cloud of Biofuel Smoke. My first task is convincing you that to speak of returning forests is plausible. My second task is to examine the cloud of biofuel smoke. A common, if not prevailing, view is that the forests are doomed, and for me to speak of returning forest is just bleak humor. The cartoon, Dad says to son, the rainforest, isn't that gone yet? A more hopeful view is one stated by a group of foresters who recently published the statement that forest transitions of the kind experienced in Europe is now spreading to the rest of the world without impoverishment or depopulation. This is what forest transitions are. France has experienced two during the medieval warming period. The forests were being cut down until in 1350 Black Death struck. France was severely depopulated and forests began to regrow. Then after a century or so they began to shrink again until about 1820, after the Napoleonic Wars, when they began to grow again, this time without depopulation. Forest transitions are not a French monopoly. Connecticut, which was the first state to experience a forest transition in America, turned around about 1830. Our forests in my home state began to expand, and that sort of transition from shrinking to expanding forests has occurred across America until during the last half century, 1953 to 2002, forests grew in 47 of the 50 states. Here are some nations that have experienced forest transitions that can be documented, beginning with Denmark, where the hams come from. It has not, forests have not spread widely there, but they are still considerably more than they were in 1810. France, you've already seen. Portugal has reforested to an extraordinary degree. Scotland, European, Russia, and then the most significant entries in the table are the last three: China, India, and Vietnam, all places with tropical forests, all places that are developing rather than developed nations, and even in those, forests are expanding. Now, when you speak of forest expansion, you usually think of area, and that's what the United Nations Millennium Ecosystem Assessment focused on as the quotation that I gave you earlier, that essentially forests are doomed. What they mean is the forest area has fallen, but an area in Switzerland has about 100 times as much timber on it as the same area would have in Turkmenistan, and right here in America, Washington State has 6 times as much timber per acre as does Oklahoma. So the game of looking at area alone is like playing poker without noticing the chips have different colors. People value forests, and they really do, for far more than area. Certainly area is important. That shows you how large a watershed is protected from erosion. It tells you how much biodiversity is sheltered, and it tells you how much forests contribute to the landscape. But volume of timber, merchantable timber, is also important because that's the lumber that makes rafters and newsprint. And we're still making newspaper. Biomass is different from merchantable timber. Biomass includes the twigs, the leaves, the branches, and the roots, as well as the stem that can be converted into tubifores. And it is the biomass that energizes the ecosystem of the forest and can become biofuel. And finally, in the present climate, how much carbon the forest holds is important. Those are all valued, but they're hard to measure. This is the way I define them. Area is area, obviously, measured in acres or hectare. Volume is the area multiplied by the density of merchantable timber, A times D. Biomass is A times D times a biomass factor, B. That's the ratio of cubic meters of merchantable timber to the tons of biomass. And finally, there is the concentration of carbon that you must multiply to get Q quantity of carbon tied up in the forest. Now, we're more interested in change than we are in standing crop. And since the Q, for example, is a product of four numbers, that means that the percentage change in Q, which is not changing very fast, is equal to the sum of the percentage changes in A, D, B, and C. You can't grasp spreadsheets of all these terms wobbling around to know whether you're winning or losing in the forest game. But we can chart them, and a graphic chart can be grasped. In this chart, latitude is density. There's an equator of unchanging density across the middle, and then the horizontal axis is area. How fast is the area changing? In the upper right-hand quadrant, the X shows that area is increasing at A% per year, density is increasing at D% per year, and the distance from that X over to the red boundary is the change in volume of timber per year, because on that red line in the upper left-hand quadrant, the increase in density is exactly countering the decrease in area. Here, and I will read it to you, is the map, a real map of the 50 nations that hold 95% of the world's timber volume. I have added a green boundary to the red boundary. As trees grow, the biomass ratio changes because more and more of the biomass is concentrated in the volume of merchantable timber. A giant redwood has almost all of its biomass in that trunk. So that means the ratio of biomass to merchantable timber goes down. That's why you have to use a slightly different boundary between increasing and decreasing biomass. The important, there are a lot of European countries that are gaining. The US is up there, Japan is up above the red line, and then those three very significant countries are highlighted in the upper above the boundary. The worst is way down in the corner there, Indonesia. It's losing both density and area. And Brazil is there. It isn't very far from zero. It's not losing a very big percentage of its forest. It's not changing its density. But because the Amazonian forest is so vast, a small change in area is a large change in total volume. A global sum, which is what people who don't want to look at that chart would use, or can't grasp anything short of a global sum, that is shrinking. The rate shrank for the 15 years from 1990 to 2005. It shrank about a 50% per year. But the nations varied very much, as you are prepared to, for me to say, because you saw the chart. 44% were losers, 41% were winners, and 15% held their own. The extraordinary thing is if you take out the two big losers, Brazil and Indonesia, the global sum is then increasing roughly as fast as the global sum with those countries is decreasing. So, part one of my talk, returning forests are possible. Part two, under a cloud of biofuel smoke. Biofuel is not a future fuel, it's a once and future fuel. And it's one that New England knows well. These are pictures of the dioramas in the Harvard Forest Museum. The forest primeval on your left, the way the Yankees had cleared it by the time of the French and Indian War, and then finally at the most extensive clearing, that in 1830. This was not cleared for crops alone. The brass mills of Waterbury were fueled with charcoal, and the forest, present forest, is dotted in Connecticut where charcoal, the charcoal kiln remains, the pits and so forth that once were there half to a century ago. The town, little town on the Long Island Sound where I live had not one but two ports, little harbors, shipping firewood to keep New York City warm. Every farmhouse had a Mount Everest of firewood behind it every fall. And President Timothy Dwight of Yale, who liked to tour New England and New York State when school was out in the summer around 1800, was a great diarist. And he wrote in his diary that the marginal land of New England and New York would be inadequate to furnish the fuel for the growing population. Of course, what happened was that fossil fuels rode to the rescue. And here you see another quotation from Calpe et al. Replacing fuel wood by fossil fuel has spared forests, aspiring that use of biomass fuel would reverse. And there you simply see the biomass fuel going down from virtually 100% in 1800 to about 3% today. I've made a calculation here, and if you write me at my email, I'll show you the details of this. The important thing is that I didn't worry about the losses that would occur between production of biofuel and your gas tank. I simply asked, how much land would it take with a very good crop? And I cite here eucalyptus, corn, oil palm. How much land would it take for those crops to fix the annual output of carbon? And the answer is 700 million hectares. That doesn't mean much, but if I tell you that is equal to the area of the Amazonian basin, it is 4 times the area of U.S. cropland, then you grasp what a big area this is. And that essentially dooms biofuel without all the complications that you might make in a calculation. Between the once and the future, there is the period of the last 7 years. And here in the United States, as the chart from the Wall Street Journal on the left shows, prices of corn have gone up even faster than the price of oil. Commodity prices during those 7 years went up 30%. Farm commodities, wonderful, went up 44%. And corn prices almost doubled, 89%. Corn production rose 32%. The the percentage of corn going into biofuel went up 156%, almost a tripling, and ethanol production more than tripled, 237% increase. Now, farmers produce some of that corn, that extra corn, by raising yields, but especially, but in addition, about half of the increase came from increasing land use. The acreage of corn in the United States went up 18% in those years. What's 18%? Well, it's 14 million acres, which is larger than the 11 million acres in the states of Vermont and New Hampshire combined. I won't even talk about the area of Connecticut. Palm oil is the poster child, I believe, the current poster child of biofuel production. First, you clear the land, you burn it, you smoke up the other islands in that archipelago. Then you plant palm and you make biodiesel as well as soap. Now, we mustn't go too far in condemning this, because you must realize that there is still a canopy there. It just happens to be producing palm oil instead of orangutans. The decline of the Indonesian forest that was so dramatic on that earlier chart, you remember it was down in the left-hand corner all by itself, really, was at the rate of 1.9 million hectares per year. Only a small part of that can really be blamed on biofuel. Only 0.2 of a million, 200,000 hectares, went into palm oil production. Other crops expanded too, but they only expanded 0.4% per year. So there is a difference of 1.3 million hectares per year about which we could do something. It is, in fact, a lot of it is, of course, being turned into lumber. In my final chart, I point out that you don't have to make biofuel in order to decarbonize. And this is a chart of the ratio, the carbon efficiency, turned upside down, of energy use in the globe and in one nation. The amount of carbon emitted per unit of energy used has gone down, which is an improvement. It's gone down about 10% in the 30 years since 1970. France, however, has gone down to about half. And I'm sure that's no mystery to you why that has happened. It wasn't biofuel. It was nuclear energy, of course. The nuclear energy production of France is now about 39% of their use. Summing up, first of all, focusing on forest acreage is blind to the colors of poker chips. You can divine several of the valued attributes by measurable variables. And then you can put them all together in what I call the forest identity. Q, carbon, is equal to area times density times biomass ratio times carbon concentration. That's no mystery. While the global totals shrink, a synoptic map or chart, the one I drew for you with Brazil and Indonesia on it, shows forests expanding in individual nations. Remember, 41% of the nations individually gained volume, and the 44% lost. It's true. The balance shifts completely to reforestation if you omit Indonesia and Brazil. And finally, I think I have shown you that biofuel does cast smoke across this hopeful view that forests can be returned. Thank you.